Welcome to Surfaces and Splines, a series of SolidWorks video tutorials presented by the DiMonte Group. In Surfaces and Splines, we'll be taking a look at the production modeling in SolidWorks of this work flashlight. In a previous installment, we took a look at some of the surface tools we'll be using to model certain portions of this flashlight, and in this installment, we'll take a more in-depth look at the boundary surface and the surface fill. The boundary surface is the workhorse of my surface modeling in SolidWorks. The boundary surface, I believe, was introduced in 2007, and it works similarly to Loft in that it best creates surfaces between a series of profiles. However, it has some advantages I find over the Loft surface that we'll get to in a little bit. Best practice when working with a boundary surface, as we talked about last week in patch layout, is to always create boundary surfaces that have four sides. The three-sided boundary surface introduces a degenerate point where two edges of the surface converge into a single vertex, and this can be problematic for downstream operations such as a shell. So here, this large boundary surface, which forms a big portion of the handle, is created from 5 total profiles. I have this profile, this profile, and this profile, 3 total in direction 1, which is the same as profile in Loft. And in direction 2, I have this curve and this curve, which is the same as guide curves in the Loft. However, unlike Loft, boundary surface can actually create surfaces from a different number of profiles. I call this type a swept boundary surface, where I'm almost creating a sweep type geometry where I'm going from this profile in direction 2 and it's following this profile in direction 1. I could also create a almost like a 2-profile sweep if I had one profile here and I'd swept along this path, and it would come to another second profile here. The boundary surface can create an enclosed boundary surface with a 4-sided perimeter. I have this curve and this curve in direction 1 and these 2 curves in direction 2. The boundary surface also has what I term the short edge boundary surface, where I have this connector which defines the start. This edge is actually longer here than this edge, and I can drag this connector back. The downside of this is that the edits aren't entirely parametric. I can't snap and add relations to this connector. I believe its position along its edge is based on its percent along the edge. Design changes may cause the connector to revert to its original position, and I have to go back into that surface feature and grab that connector and drag it back again. The boundary surface also can trim back. So here I have these long profiles in direction 2, followed by this first profile in direction 1 and this profile in direction 1. And if I didn't have the trim back option, it would actually create a surface that followed all the way along these profiles in direction 2, whereas the trim option, trim by direction 1, which is this curve, creates a shorter surface. The boundary surface also supports curvature continuity in both directions, unlike Loft, which only supports it in the profile direction and not the guide curve direction. Loft only supports tangency in the guide curve direction. When adding these constraints, you might get this error message. The guide curve or profile curves at its end point does not match the curvature the surface touches. I find you can just ignore these messages. There might be a very, very slight mismatch, usually on the order of less than 0.01, usually more like 0.001 of a degree. So for all intents and purposes, the surfaces are tangent there. SolidWorks is just telling you it's not absolutely perfect, but in the real world it doesn't matter. The other nice thing I like about boundary surface is the curvature display. You can change the mesh density here, but you get a feedback of what the curve is doing. Here I'm using these combs to evaluate this flat surface and this flat surface. The curvature of this filleted blend is coming down to 0. We do have a curvature continuous connection. Loft does not support this 2014 through previous versions. In SolidWorks 2015 they added this curvature display option to the Loft command as well. The other thing boundary surface has is the tangent influence, and this can kind of be thought of as how much do you want to inflate the surface. If we jump into SolidWorks here, and this big surface forms the top bottom of the drill. or sorry, at the flashlight. And if I have the tangent influence slider down at 0, if I zoom in here, we actually see that the curvature kind of tapers off here. We want consistent curvature all the way along the surface, and if we zoom in here, I can actually see that the surface is almost inflecting here. So this could cause an issue right here if it's not the cleanest. So if I bump this tangent influence up to 100, I now have cleaner curvature through here. So it can kind of be thought of as how much do I want to inflate or pump up the surface. The surface fill is one of the most powerful features in SolidWorks, and unlike the boundary surface, surface fill has the ability to create a patch with an n number of surface edges, where n is the number of edges that define the patch boundary. Often I use it to create 3 or 5-sided patches. So here I wouldn't be able to create this geometry with a boundary surface. There's no way I can go from this edge to this edge along here and here, 5 sides. So I will use the surface fill. What surface fill does is it generates a large 4-sided surface and trims it back. Here in this yellow grid outlined by the red rectangle, we see the actual shape that the surface fill is generating, and then it's being trimmed back. I can turn the preview mesh on and off to see what this preview looks like. So as a best practice when using the surface fill tool, even though we may want a curvature continuous connection, it's best to start off with tangency on all edges instead of jumping right to curvature. Adding curvature to edges can cause bumps and dimps and ripples in the surface fill, like we see in this example where curvature is applied to these 3 edges. Whereas with tangency, I have much cleaner geometry. It's always better to start with the tangent relation and then use those surface analysis tools we talked about earlier, the zebra stripes and the curvature display, to evaluate just how good your connection is. So thanks for joining us this week. Follow the DiMonte group on LinkedIn for new videos.